Hi, my name is Jamshed Damkyala. I'm a lead PM on the .NET Core Platform team. I'm here to give you a peek at a new feature in the .NET Framework 4.5.1. As you know, SQL connections in cloud scenarios like the Azure database have an inherent degree of unreliability as compared to local SQL client-server connections. This is due to several factors, including issues with internet connectivity, databases in clusters failing over, switching partitions, etc. These errors are typically transient, so a retry would probably fix the issue and the connection would work. But users need to write code with retry logic in their client apps for these issues. We see that many users typically do not do this, so we built an additional level of resiliency in the connections. This is a small app I wrote to demo this feature. This is a contacts database app. It is a WinForms client that uses ADO.NET to connect to a SQL Azure database and fetch some data. The way it works is I enter a search term in the app, and the app runs a query against the database and finds the contact whose name matches the entered text. If found, the app then displays the properties for that contact. The app is built using .NET 4, not 4.5 or 4.5.1. Let's look at the SQL database for a second. This is the SQL database. It's a SQL Azure instance. Here we have a contact table called table contacts. We have the primary key, which is the ID. We have the contact's name by which we are going to do a lookup. We have the address, the cell phone number, home phone, and email ID. I have also pre-populated the table with a couple of rows of data. We have John Doe, Jane Smith, Tom Sawyer, Huck Finn. Let's look at the app again. This is the application startup code. We have function main, and the first thing function main does is open cloud database connection. Once the application finishes running, it calls close database cloud connection. We have in the open cloud DB connection method, we have a connection string we are reading from the app config. We are instantiating a new SQL connection object and calling open on it. Close connection simply closes the connection. As you can see, there is no retry code here. There is nothing to reestablish the connection if it's broken. Now let's look at the code behind the search button. This is the method, search button click. Here we take the user's input string and we create a SQL query based on this. In a real world app, we never pass on the user's input as is without sanitizing it, of course, because we might be open to SQL injection attacks. But this is a demo app. As you can see here again, there is no code to establish a connection or re-establish a connection if it's broken. All we are doing is using the existing connection which was previously opened at application launch and invoking the SQL command object. We read the data, we fetch the data back, and the data that comes back is shown to the UI. Now we are ready to run the app, but before we run the app, I'm going to start up TCP view first, so you can see the database connection get established on the fly as it happens. Now I'm going to run the app, and as soon as we start running the app, we can look at TCP view, and here we have the SQL connection that just got opened. Connect to my database. We see that the local port is 61732, the remote port is Microsoft SQL Server, and the connection is open and waiting. So we're going to do a search. We're going to search for John, and here we have some data back for John Doe, and we have his address, email ID, cell phone number, home phone. We're going to also search for Jane, and we have Jane's information come back. Notice how the same database connection was used. The app does not establish a new connection for every search. Now what I'm going to do is kill this database connection while the app is still running. This emulates what might happen in the real world when there's a flaky connection over the internet or a database instance in a cluster fails over. I think we all know what happens when a database connection is dropped. Let's try the search again. There we get a connection error since, as I mentioned previously, there was no logic in the application to try to re-establish the broken connection. So we'll shut down this app now. Now we are going to repeat the same demo on another machine that is running the exact same app. It still does not have any retry logic to re-establish the database connection. The only difference this time is that the .NET Framework runtime version is .NET 4.5.1. The app itself is still built to target .NET 4. Just as I did previously, before running the app, I'm going to start TCP view first so you can see the database connection established on the fly when it happens. There we see the database connection is established. The local port is 33273. So let's do a search. We look for John again, and we have John Doe's data come back. And we could again do the same search for Jane. And the same connection, 33273, the local port, was reused. Now once again, I'm going to try to kill the database connection on the fly while the app is still running. And there it's gone. And now I'm going to do a search for somebody else. Let's look for Tom Sawyer. There. Did you see the connection magically reappear? As I mentioned, there is no code in the app to re-establish the connection. ADO.NET does this automatically behind the scenes for you. This concludes this demo of the ADO.NET Connection Resiliency feature in .NET 4.5.1. As you saw in this segment, simply changing the version of the .NET Framework runtime for your application from .NET 4 or .NET 4.5 to .NET 4.5.1 will help reduce the number of times a client application will see transient connection failures. No other changes are required to the application. You do not need to rebuild your application to target .NET 4.5.1 in order to benefit from this feature. Thanks for watching.